Have you ever heard of the man who discovered gravity after watching an apple fall from a tree? What if that apple wasn't just a fruit, but the spark that changed science forever? Today, you're about to enter the world of Isaac Newton. But this isn't just a story about a scientist. It's a journey into the mind of a genius who saw the universe differently. This is not a history lesson. It's a chance to improve your English, sharpen your listening, and learn new vocabulary through real storytelling. So find a quiet space, put on your headphones, and let the story carry you. The language is graded, the narration is clear, and every sentence is here to help you learn. Get ready to travel through time and explore the life of one of the greatest thinkers in history. Let's begin the story of Isaac Newton. Have you ever wondered how a tiny, sickly baby born on a cold winter night changed the world forever? What if I told you that this baby, who wasn't expected to live even one day, would grow up to rewrite the rules of science? In the year 1642, in a small village called Woolsthorpe in Lincolnshire, England, a child was born who was so small, so fragile, that no one thought he would survive the night. His name was Isaac Newton. The wind howled outside as his mother, Hannah, held him tightly in her arms. He was born prematurely, without a father, and weighed little more than a single loaf of bread. Doctors at the time could do very little for such a baby. There were no incubators, no advanced medicine, no special care units. But somehow, Isaac survived. Somehow, against all odds, this tiny child began a life that would become one of the most extraordinary in human history. From the beginning, Isaac Newton was different. He didn't speak much, and he often seemed lost in his thoughts. While other children played, Isaac would sit alone, watching the world with quiet eyes. He noticed things others missed. The patterns of the clouds, the motion of the wind, the shadows on the ground. He was a boy of few words but deep thoughts. Even as a child, his curiosity was endless. Isaac was raised by his grandparents after his mother remarried and left him behind. This separation may have made him feel lonely, but it also gave him time to think, to imagine, and to explore the world inside his mind. He built small mechanical toys with his hands. He made tiny windmills powered by mice running on wheels. He crafted water clocks that measured time with dripping water. He carved sundials into the walls of the house, carefully noting the movements of the sun. No one taught him to do these things. He simply watched, wondered, and then created. At school, Isaac was not an outstanding student at first. In fact, he was near the bottom of his class. He wasn't particularly interested in the lessons that his teachers gave. He preferred reading books and doing small experiments by himself. That changed one day when he got into a fight with another boy. The boy had teased him, and Isaac decided to do something unusual. He would become better than that boy, not by fighting, but by studying. From that day forward, Isaac threw himself into his studies. He read every book he could find. He stayed up late at night, reading by candlelight, eyes wide with curiosity. He memorized facts, solved problems, and began to rise to the top of his class. It was as if a switch had been turned on inside him. Isaac had discovered the power of knowledge, and he couldn't get enough. As he grew older, his questions became bigger. He didn't just want to know how things worked. He wanted to understand why. Why did objects fall to the ground? Why did the moon stay in the sky and not crash into Earth? Why did light bend when it passed through glass? These were not easy questions. These were questions that no one in the world could yet answer. But Isaac didn't give up. He believed that the universe was a puzzle, and he was determined to find the pieces and fit them together. One day, he saw a kite flying in the wind. He asked himself why it stayed in the air and why it moved the way it did. He saw a spinning top and wondered what made it spin so smoothly and then suddenly stop. He noticed the shape of soap bubbles and how the colors danced on their surface. These were small things, everyday things. But to Isaac, they were mysteries to be solved. He once spent hours sitting by a window, just watching raindrops slide down the glass. He counted how many drops fell in a minute, how fast they moved, how they changed shape. Some people thought he was strange. Some said he was wasting time. But in his mind, Isaac was collecting data, building ideas, asking questions that no one else dared to ask. His imagination was as powerful as his logic. When he wasn't experimenting, he was building, not with blocks or toys, but with ideas. He drew diagrams, sketched inventions, and filled notebooks with thoughts. He wrote out lists of problems and then tried to solve them one by one. Even as a young boy, Isaac dreamed of doing something important. He didn't know what it would be, but he knew he had to keep learning. He was hungry for knowledge, and this hunger drove him forward. His school teachers began to notice. They saw that this quiet, odd boy had a brilliant mind. They encouraged him to study more, and soon it was decided that Isaac should go to university. He would attend Trinity College at Cambridge, one of the most respected schools in England. His family was not wealthy. They were farmers, and it was hard to afford the costs. But Isaac worked as a servant to pay his way. He cleaned rooms, served food, and helped other students, all while continuing his studies. This was the beginning of a great transformation, from a lonely boy in a small village to a scholar at a great university. But even before he set foot at Cambridge, Isaac Newton had already shown signs of greatness. Because what made him special was not just his intelligence. It was his curiosity, his ability to wonder, and his determination to find answers. He believed that the world was full of secrets, and that those secrets were waiting to be discovered. So when people ask, how did Isaac Newton change the world? The answer begins here, with a small, quiet boy who asked big, powerful questions, with a child who stared at the stars and wondered what held them in place, with a young mind that saw the universe not just as it was, but as it could be understood. This was the beginning, this was the spark, and it all started with one question: why? At Trinity College, Cambridge, Isaac Newton stepped into a world filled with ideas, books, and brilliant minds. But he didn't fit in right away. He was shy, quiet, and often kept to himself. While other students gathered in groups to discuss politics or gossip, Isaac spent most of his time alone. He didn't care for fashion or status. He didn't come from money or noble birth. Instead, he brought with him an unstoppable hunger to learn. He spent hours in the library, reading the works of ancient philosophers like Aristotle, Descartes, and Kepler. But he wasn't satisfied with their answers. He wanted to ask his own questions and find his own truths. His mind moved quickly, jumping from one idea to the next. He studied math, optics, astronomy, and mechanics. He began filling notebooks with thoughts, diagrams, and strange formulas. These pages would later be recognized as the beginning of revolutionary theories. In college, Isaac was introduced to the concept of mathematics as a language of nature. He discovered geometry and algebra as tools to describe the universe. He was especially fascinated by how numbers could explain motion and change. He began to think about motion in a new way, trying to find patterns where others saw chaos. He observed pendulums swinging and thought about how time could be measured by their rhythm. He imagined the stars and planets moving through space like giant clocks, governed by invisible forces. But just as Isaac was settling into academic life, the world outside changed dramatically. In 1665, the Great Plague reached Cambridge. The university shut down to prevent the spread of the disease. Students and professors were told to leave immediately. Isaac packed his belongings and returned home to Woolsthorpe. Many saw this as a disaster. But for Isaac, it was the beginning of his most creative period. Now, without teachers, without classmates, without distractions, he was free to think. He walked alone in the fields, sat in silence under trees, and let his mind wander. He started asking new questions, bold, almost unimaginable ones. What if the same force that makes an apple fall also keeps the moon in orbit? What if motion wasn't just a mystery, but a law? Could there be universal rules that govern everything from falling objects to the movement of planets? These thoughts grew stronger each day. He began writing and calculating nonstop. His small room became a lab of the mind. He used prisms to study light, separating it into colors. He discovered that white light was made of many colors, not just one. This was a completely new idea. He also began working on a new kind of mathematics, one that could describe change, speed, and movement, what we now call calculus. Though he didn't publish it at the time, Isaac Newton had invented a whole new mathematical system, and he did it while isolated during a deadly plague. As the months passed, his ideas continued to grow. He observed how objects moved through space. He tested different surfaces, angles, and materials. He dropped things, rolled things, bounced things, all to see how motion worked. He began to notice patterns. He realized that there were rules, consistent rules, that governed these motions. From a young man staring at an apple tree to a scientist forming the foundations of physics, Newton was changing before anyone noticed. But he didn't care about fame or recognition. He didn't rush to publish or speak at events. Instead, he wrote and rewrote his notes. He tested his ideas again and again, making sure they were right. This time of solitude, what historians call Newton's annus mirabilis, or year of wonders, was filled with breakthroughs. Gravity, optics, calculus, he planted the seeds for them all, and yet few knew what he had done. He was just a young scholar who had returned home for safety. But in truth, He was quietly building a new science. He was solving problems that had puzzled the greatest minds for centuries, and it all happened because he was alone, because he had time to think, because in his heart Isaac Newton was never afraid of asking the biggest questions, even when no one else was listening. While the world outside struggled with disease and death, inside Newton's mind, a revolution was beginning, one that would soon transform the way we understand the universe. What others saw as an ending, Newton saw as a beginning, and from that moment, nothing in science would ever be the same again. When Isaac Newton returned to Cambridge after the plague, he was no longer just a student. He was a man with answers to questions no one else had dared to ask. His professors noticed the change. His fellow scholars began to respect him, even if they didn't fully understand him. He spoke little, but when he did, his words carried weight. His ideas were not only new, they were powerful. He was invited to become a fellow of Trinity College. This meant he could teach, research, and live at the university. But Newton didn't want to teach in the traditional way. He didn't just want to repeat what others had said before him. Instead, he continued developing the thoughts that had taken shape during his time at Woolsthorpe. One of his major areas of focus was motion. He wanted to describe how and why objects moved. What force caused them to speed up, slow down, or change direction? It was in this pursuit that Newton formulated what would become known as the three laws of motion. The first law: an object in motion stays in motion unless acted on by another force. This explained why a ball would keep rolling unless something stopped it, like friction or a wall. The second law: force equals mass times acceleration. This told us how much force was needed to move an object and how mass affects movement. The third law: for every action there is an equal and opposite reaction. This explained why when you push on something, it pushes back with the same force. These were not just clever ideas. They were laws, rules that could predict how everything from a falling rock to a flying cannonball would behave. For the first time in history, people could explain motion using math. They could calculate, predict, and design with confidence. But Newton didn't stop there. He asked an even deeper question: what keeps the planets in their orbits? Earlier scientists like Kepler had described how planets moved, but Newton wanted to explain why. He connected his ideas about falling objects with the motion of celestial bodies. He proposed that the same force pulling an apple to the ground was also holding the moon in orbit. This force, gravity, was universal. It acted between all objects everywhere all the time. No one had ever described the universe in such a unified way. Newton's ideas didn't just apply to Earth, but to the entire cosmos. In 1687, after years of thought, research, and calculation, Newton published his greatest work. It was titled Philosophiae Naturalis Principia Mathematica, often shortened to Principia. This book was a milestone. It laid out his laws of motion and his law of universal gravitation. It wasn't an easy book to read. It was filled with complex mathematics and dense reasoning, but it changed everything. It gave scientists a framework to understand the physical world. With Newton's laws, people could now predict the movements of planets, the flight of projectiles, and the forces at work in machines. Engineers, astronomers, and philosophers were stunned. They finally had a set of tools that worked. Even Newton's critics admitted his genius, and slowly his ideas spread across Europe and beyond. The Principia marked the birth of modern physics. It was a bridge between the ancient world of Aristotle and the new scientific age. But Newton himself remained humble. He once wrote, "I do not know what I may appear to the world, but to myself I seem to have been only like a boy playing on the seashore, finding a smoother pebble or a prettier shell than ordinary, whilst the great ocean of truth lay all undiscovered before me." He knew there was still so much to learn, and he continued to study, to experiment, and to write. His curiosity never faded. His desire to understand remained his guiding light. In creating his laws of motion and gravity, Newton didn't just explain how things moved. He gave humanity a new way to see the universe. He showed us that nature follows rules, that behind the beauty of the stars and the falling rain there is order, and that if we are curious and brave enough to ask, we just might find the answers. Despite the success of his groundbreaking work, Isaac Newton's life was not without conflict. Genius often invites challenge, and Newton was no exception. As his reputation grew, so did the scrutiny of his work. Other scientists, jealous or doubtful, began to question his ideas. One of his most famous rivals was Robert Hooke. Hooke was a respected member of the Royal Society and had also studied light and motion. When Newton began sharing his ideas about light and gravity, Hooke accused him of stealing concepts. He claimed that he had thought of many of these ideas first. Newton, who was known for being sensitive and private, did not take this lightly. He became angry and withdrawn. For years, their rivalry created tension within the scientific community. Each man wanted recognition. Each believed his ideas were the foundation of progress. But Newton had something more than just ambition. He had precision, discipline, and a relentless commitment to proof. Even though he hated public disputes, he defended his work fiercely. He knew that his theories had come from years of deep thinking and careful observation. Over time, more and more scientists began to support Newton's ideas. His reputation as a thinker and mathematician continued to grow. Eventually, Newton took on a new role. He became president of the Royal Society in 1703. This was a powerful position, one that allowed him to guide the direction of science in Britain. Some say that after Hooke's death in 1703, Newton used his influence to erase Hooke's legacy. There are no known portraits of Hooke today, and some believe Newton had a hand in that. Whether or not that's true, one thing is clear. Newton was now the face of English science. He led discussions, judged experiments, and shaped the future of scientific thought. But Newton's work didn't end with astronomy and motion. He also took a deep interest in something very different: money. In 1696, he became warden of the Royal Mint. His job was to oversee the creation of coins and protect the currency from counterfeiters. This may seem like a strange job for a scientist, but Newton took it very seriously. He brought the same precision and logic to the mint that he had brought to science. He reorganized the system, improved coin quality, and introduced new measures to stop forgeries. He even personally investigated and prosecuted counterfeiters, leading to many arrests. One of the most famous cases involved a man named William Challoner, a master counterfeiter. Newton tracked him down, gathered evidence, and helped send him to the gallows. His success at the mint earned him respect far beyond the world of science. He was seen as a man who brought order to chaos, whether in nature or in finance. In 1705, Queen Anne knighted him for his service to England. He became Sir Isaac Newton, a title that honored both his intellect and his public service. Yet, even with fame, power, and a knighthood, Newton remained a complex man. He was often alone, deeply focused, and obsessed with his work. He kept writing, exploring topics from biblical prophecy to alchemy. Yes, alchemy, the ancient and mystical practice of turning base metals into gold. Many people don't know this, but Newton wrote more about alchemy than he did about physics. He believed there were hidden forces in nature still waiting to be discovered. Some of these writings were kept secret during his life. They were considered controversial and unscientific. But to Newton, all knowledge was connected. Whether it was motion, light, money, or magic, he believed that truth was out there and it could be found. He chased truth with every breath, every hour, every page he filled with his tiny, careful handwriting. He was not just a scientist, he was a seeker. And that quest, that drive to understand everything, defined the man behind the mind. In public, he was a hero of reason. In private, he was a soul driven by mystery. And both sides of him were equally real. In the final chapters of his life, Isaac Newton stood at the height of power and recognition. But the journey had changed him. He was no longer the quiet boy from Woolsthorpe who watched raindrops race down windows. Now he was a figure of authority, respected across Europe, and at times feared. As president of the Royal Society, Newton held enormous influence over the scientific world. He decided which ideas would be supported and which ones would be dismissed. Young scientists would carefully approach him, hoping for approval. A kind word from Newton could launch a career. A critical comment could end one. Some say he became overly protective of his legacy. He guarded his work fiercely, and at times, his pride got in the way of collaboration. One of the most famous disputes of his later years was with the German mathematician Gottfried Wilhelm Leibniz. Both Newton and Leibniz had developed calculus, but in different ways and at around the same time. When it became public, a bitter argument followed. Who had invented it first? Who deserved credit? The battle turned personal. Letters were written, accusations made. The Royal Society, under Newton's leadership, launched an investigation. The result favored Newton, but many historians believe the process was unfair. Newton, they say, used his position to shape the outcome. Whether or not that's true, the feud damaged both men. It divided the English and continental European scientific communities for decades. And it revealed something deeper about Newton. his genius was matched by a powerful need for control. He wanted not only to discover the truth, but to own it. Even in retirement, Newton remained busy. He continued as master of the mint, fighting counterfeiters and improving Britain's currency. He attended meetings at the Royal Society and kept close ties to scholars and statesmen. Visitors from all over the world came to see him. They asked questions, took notes, and marveled at the man who had changed science forever. Some found him charming. Others found him distant, even cold. He lived alone, never marrying, never having children. But he was never truly alone. His mind was always full of questions. He wrote thousands of pages in his final years, not only on physics, but also on theology, alchemy, and history. He tried to predict the end of the world using Bible codes. He searched for the wisdom of ancient civilizations. His curiosity never narrowed, it expanded. Even as his body aged, his imagination stayed young. In 1727, Isaac Newton died in his sleep at the age of 84. He left behind no children, no family of his own, but a world transformed by his thinking. He was buried in Westminster Abbey, a rare honor usually reserved for royalty. His tomb still stands there today, visited by scientists, students, and admirers from every corner of the globe. He had become more than a scientist. He had become a symbol of human reason, of curiosity, of the power of the mind. And while he may have struggled with pride, rivalry, and loneliness, he never stopped seeking truth. The boy who once stared at the stars had helped humanity reach them. And in doing so, he lit a path that countless others would follow. Isaac Newton's legacy did not end with his death. In fact, it was just beginning. His ideas, written in thick Latin texts and scribbled notebooks, would shape the world for centuries to come. What he left behind was not only a set of scientific laws, it was a new way of thinking. Before Newton, people saw nature as mysterious and unpredictable. After Newton, they saw it as logical, organized, and explainable. He gave humanity a method, a way to ask questions, test answers, and build knowledge through observation and reason. This became the heart of the scientific method. Thanks to Newton, engineers could build bridges and machines with precision. Astronomers could predict the paths of planets. Mathematicians found new tools in the calculus he had invented. Philosophers found new meaning in the idea that nature followed rules, not randomness. Even centuries later, his work continues to influence the world. When we launch rockets into space, we still use Newton's laws. When we build skyscrapers or send satellites into orbit, we rely on his understanding of motion and force. In classrooms around the world, students learn his principles as the foundation of physics. But Newton's legacy is not only scientific, it's also deeply human. He showed us that it's possible to start with nothing, with loneliness, with questions, with curiosity, and reach greatness. He proved that knowledge is not only for the privileged, but for anyone willing to look, to wonder, to work. He showed that failure and conflict do not erase achievement, that passion can overcome hardship. And perhaps most importantly, he reminded us that there is always more to learn. Even as he lay dying, Newton said he felt like a boy playing by the seashore, discovering a prettier shell now and then, while the great ocean of truth lay undiscovered before him. That humility, that hunger for understanding, is what truly defined him. His laws and theories are carved in textbooks, but his spirit lives in every question we ask, every experiment we try, every mystery we dare to explore. Newton helped us see the universe not just as stars and stones, but as a vast system waiting to be understood. He made us believe that with patience and thought, we could discover the hidden rules of nature. He changed not only what we know, but how we learn. And that is a gift that continues to shape every scientist, every student, every dreamer. So when we look at the sky, when we drop a ball, when we bend a beam of light, we are, in some way, still walking beside him, still guided by the questions he asked, still learning from the mind that helped humanity rise from mystery into understanding. This is the legacy of Isaac Newton, a legacy of wonder, a legacy of reason, a legacy that reminds us. The greatest discoveries often begin with the simplest question: why? You've just heard the incredible story of Isaac Newton, a man whose curiosity shaped the modern world. From a tiny village in England to the heights of scientific discovery, his journey proves that great things begin with great questions. If you enjoyed this story, take a moment to reflect on what you learned, both about Newton and your English. What words were new to you? What ideas inspired you? Feel free to watch again, pause, rewind, and practice the parts you loved. Every time you listen, you're building stronger skills. And remember, Learning a language is like discovering the laws of nature. It takes time, focus, and a little wonder. If you liked this video, don't forget to like, subscribe, and share it with others who are also learning English. Let's keep learning together one story at a time. Thanks for watching and keep asking why.